Hello guys, this is Sumadhu here. This is problem number 11 from module B of linear programming from 12th edition of operations management. Now let's try to solve a maximization problem wherein we are given a problem wherein each coffee table by Watson Designers sells for $9. They also sell a bookcase that yields $12. So let's bring this to a point wherein we can visualize the problem. So let's see the given information. Let's start to write it down. Let's say we have so let's say we have a coffee table that sells for $9. We also have a bookcase that sells for $12. It's a small business and resources are limited given during any production for a week. 10 gallons of varnish and 12 lengths of quality wood are available. So let's say they have varnish and they have the length of wood, length of redwood. Oops, this is our previous problem. Okay, come on. Okay, so this was 10 and this was 12. That's what's given to us so far. Let's continue. So each coffee table requires approximately 1 gallon of varnish and 1 length of redwood. So coffee table requires 1 gallon of varnish and 1 gallon of redwood. Okay, and the bookcase requires 1 gallon of varnish and 2 lengths of redwood. Find the product mix as a linear programming and solve how many tables and bookcases should be produced each week. So what will be the maximum profit be? So let's say we were to make x1 number of tables and x2 number of bookcases. Then our profit function or objective function would be 9x1 plus 12x2, and we want this to be maximized. At that point, the constraint for varnish would be 1 times x1, 1x1 plus 1x2 should stay less than equals to 10 gallons of varnish that is given to us, and the constraint for redwood would be 1 gallon of x1 plus 2 gallons of 1 length of redwood for the table and 2 lengths of redwood, and they should stay less than the 12 length of total redwood that is given to us. So it's 9 times x1 plus 12 times x2 that goes in the profit function, and then whatever the number of units of table and bookcases come out to be at the same time, it will be 1 times x1 plus 1 times x2 should stay less than equals to 10, and 1 times x1 and 2 times x2 should stay less than equals to 12. So that's what we have, and at the same time we should keep in mind that x1 and x2 should be 0 or more, so they cannot be negative values. Okay, so they have to be greater than equals to 0. Now let's bring this same problem into the spreadsheet, so then we can use the data solver, Excel solver. Okay, so first let me type, we will follow the same pattern. this is for coffee table, and this is for bookcase x2, and I'm going to highlight this as our decision variables. Let those x1 and x2 change. So I'm going to call these as decision variables. Decision variables. So at this time, I know this one sells for 9, this one sells for 12, and these two are dollar values, so Control Shift 4. Therefore, at this time, the profit becomes sum product of cells to the left, comma, the decision variables, and I'm going to freeze the decision variable by hitting F4, close the parenthesis, and this is also Control Shift 4. Therefore, the format is in dollar value. Okay, and this is our profit, and this is what I want to maximize. So I'm going to color it green such that it's easy for me to identify when I'm using the solver. Now all this has to be done using constraint for varnish such that okay, where is this now? Okay, so I was saying constraint for varnish is whatever the decision variables is. It takes 1 gallon of varnish. For bookcase, we need 1 gallon of varnish, and then again, if I was to Control C, copy and then paste this same thing as formula, it helps us save a little bit of time. And let this calculated value be in blue color. This has to stay less than or equals to the given value of 10 gallons. Okay, this is same as the information that we followed in here. Okay, and is also the same as here. So 10 gallons of varnish is available. Okay, so then we also have constraint for redwood such that it takes 1 gallon for 1 gallon of varnish and 1 length of redwood. This was for coffee table, and which we've already put in here. Now this is for 1 gallon of varnish and 2 lengths of redwood. So this would be 1 and 2. Okay, and this has to be less than or equals to the given total length for redwood, which is 12. Okay, so we're going to put 1 here, 2 here, and then same as the one above, same sign, because it has to stay less than the given constraint of 12. Now this is in lengths redwood, and this is in gallons, the constraints. Let's label this as well, because this is what it's going to pick up in the sensitivity report. So we better label them such that it's useful for us to understand there. Okay, so, and let me bring this on this end. Okay, now let's check our formulas. If I was to make 1 unit of each, then I make 9 times 1 plus 12 times 1, so 12 plus 9, 21. And by this time, by making 1 unit of each, we are using 1 gallon for the coffee table. We are using 1 gallon for 1 gallon of varnish for the bookcase, so a total of 2 gallons. And at this point, this condition holds true, so 2 is less than 10. At the same time, by making 1 unit of coffee table, we've used 1 length of redwood, and we've also used 1 times 2 lengths of redwood for the bookcase, so a total of 3, and 3 does stay less than 12. So far our formulas are working correctly. So at this point in time, this is our sheet. Okay, so let's go to data solver, and we say that this is our objective function, the green cell E9. We want this to maximize our profit, so yeah, that is also correct. And then we choose the yellow cells by changing these variable cells such that we add the conditions. This cell has to stay less than or equals to the right hand side, and we add one more wherein this calculated constraint for the redwood has to stay less than or equals to 12. This is the last constraint, so I'm going to hit OK and make sure this is checked. This takes care of the problem that x1 and x2 have to be less than or equals to 0, which means if we were to look at x1, this can be either 0 or more. There is no such thing as making negative number of coffee tables and bookcases. Okay, so and then we want to use the simplex linear programming algorithm, and then we hit solve, and so once you hit solve, you should get a dialog box like this. So we will keep this as keep solver solution, so then I can see 8 and 2, they should be left there as is. Then we click sensitivity and hit OK, and then that should give us this report, and we will interpret that. But before that, let's look at our solver at this time. We are using 8, what the solver says is that we should make 8 units of coffee table and 2 bookcases per week, because remember the problem was in terms of per week, 1 week. Yeah, so by doing so, we will use 8 times 1 gallons of coffee table, 8 times 1 gallons of varnish for the coffee table, and 2 times 1 gallons of varnish for the bookcase. At the same time, we will be using 8 times 1, so 8 gallons of 8 lengths of redwood, and 2 times 2 plus 4, so a total of 12 lengths of redwood, which is exactly equals to the given value. So in this case, what we are seeing is that our resources have been fully utilized. Now this is just a coincidence. I mean, this may not always be the case. There's always there might be a case wherein you have some surplus left. So I forgot to color this one. Let me color this one as light gray, such that we know that this is our given values. Okay, now let's interpret our sensitivity report. First off, we know that the final values for the constraint for left hand side varnish is 10, and the right hand side was 10, so there's no surplus left. Okay, at the same time, if we were to relax the constraint for varnish by 1 unit, okay, that means our profit function would improve. Let me show it to you side by side. View, new window. Okay, so let's see. Now we can see the sensitivity report and the problem. So here I have the problem. On this end I have the problem, on this end I have the sensitivity report. Now we had a constraint of 10, we have constraint of 10, and the way it takes the naming for this is the first alphabet to the left of any variable and the first alphabet to the top. So that's how it names this constraint varnish left hand side. So that is why following a pattern helps us. Now all of the constraints have been used, so left hand side is exactly equals to right hand side. Then the shadow price is of 6, which means if we were to relax the constraint of varnish by 1 unit, so instead of 10 gallons, if this was to be 11 gallons, then our profit function would increase by plus $6. Now this is the shadow price for the constraint of varnish. Now remember, everything in the sensitivity report is when you change only one thing at a time. Also, if somebody was to think of increasing this right inside variable, then the allowable increase is 2 and the allowable decrease is 4, which means the shadow price of $6 is true for 10 plus 2 and 10 minus 4, which is 10 plus 2 12, 10 minus 4 is 6. So in the range of 6 and 12 for the constraint of varnish, we can increase our profit by $6 for every 1 gallon. Now on the same hand, if we were to consider the constraint for length of redwood, then we have 12 lengths of redwood that have been used out of the 12 that were available, and it has a shadow price of 3 with an allowable increase of 8 and decrease of 2, which means if you were to allow one more length of redwood, it will help improve our profit by $3. Now we can continue doing this for 8 more lengths because allowable increase is 8. So the range is 12 plus 8 and 12 minus 2. 2 is coming from allowable decrease. Within this range of 20 lengths of redwood and 10 lengths of redwood, we can expect the increment of profit in $3 at a time for every 1 length of redwood added. Now you will also notice that our reduced costs are 0, okay, in this one. And if you were to change the coefficients, which is the $9 and $12, now again this is only when we'll change one thing at a time, okay. So if we were to change this price of $9, we can still stick with the combination of 8 and 2 and we'll still have a feasible solution under the circumstances wherein this one stays 10 gallon, this one stays 12 lengths of redwood, such that the price of this $9 can be increased by x1, C8, decision variable x1. So decision variable x1, the price for this one has an increase, allowable increase of 3 and allowable decrease of minus 3 coming from here and here. It also says that for the coefficient of 12 we have allowable increase of 6 and allowable decrease of 3. So this price can vary between 12 plus 6 and 12 minus 3. So this is $18 and this is $9, and we'll still have a feasible solution, everything else being same.